Hello viewers, it's good to have you back. I've just established what geometry is all about in the previous session. I've also established the angles that are formed as far as parallel lines are concerned, and these angles are corresponding angles being equal. Alternate angles also they are equal. Vertically opposite angles are equal, and of course interior opposite angles are what? Supplementary. Now on the screen we want to solve an example where you can see that figure there. We have two parallel lines there, L1 and L2. We have a transversal line meeting at a point called X, two transversal lines, and we are asked to find those values there, X, Y, and of course Z. So we have L1 here and we have L2 here. Now we have to find the values of these angles, X, Y, and Z. Now if you look carefully, where you have the first straight line there, you have 120 degrees and you have Y. One thing I felt I forgot to inform you in the previous session is that sum of angles on a straight line will always give you 180. Angles on a straight line will always add up to 180. Alright, so here we have this straight line here. L1 is a straight line, the first parallel line, and we have 120 degrees and Y, meaning 120 degrees plus Y is equals to 180. The reason is that they are angles on a parallel line. They are angles on a straight line. Okay, so if I make Y here the subject, I have 180 degrees minus 120 degrees. So Y is equals to 60 degrees. We've gotten the value for Y. If you look at the second parallel line below, L2, you notice that Z and 180 is also sum of angles on a straight line, which will give you 180. So we can equally say that Z plus 80 degrees is equals to 180 degrees, angles on a straight line. So this means that Z is equals to, if we make Z the subject, we have 180 minus 80. So Z is equals to what? 100 degrees. We've gotten Z as 100 degrees, and also we have gotten Y as 60 degrees. Now if we come back here, we are trying to find X here, and of course X here is angle at a point. That is angle at a point which is like a circle, 360 degrees. Now we try to bisect that point into two. We come here and we draw a line out like this. Okay, now you notice that what is here and what is here are alternate angles. You can see something like a Z at that point. What is here, let's call it M, and what is here, let's call it N, are what? Alternate angles, and alternate angles are equal. That's like a Z. Alright, now but this Y that is here and this M that is here are now vertically opposite angles. Vertically opposite. M is just directly opposite Y, vertically opposite angle, and they are equal. So that means this place called M is 60 degrees because Y was 60 degrees. So we can call this M now 60 degrees. And of course here, if I also come to this place I call angle K, you can notice that we also have an alternate angle here. This angle alternates. So K and Z are alternate angles. Okay, so Z here was 100 degrees. That means K here is also 100 degrees. So what I now have here as angle at a point, this 60 degrees here, if you draw something like a Z here, M and 60 are alternate angles too. So this place is 60 degrees and this other one is 100 degrees. Okay, so everything here now is angle at a point. Everything here is angle at a point, which means X plus N plus K equals to 360 degrees. Angle in a circle is 360. So if you have a circle, angle at a point at the center will always add up to 360. So that place I'm having X with the other two angles N and K that I've introduced will give me angle at a point, and angles at a point will give you 360 degrees. So we add everything and we equate to 360. So we have X plus N is 60 degrees plus K is 100 degrees gotten from Z earlier, okay, as alternate to Z. Okay, so this equals to 360. So we have X plus 60 plus 100 will give you 160 degrees, and this equals to 360 degrees. So X is 360 minus 160 degrees. So of course you can see that X is equals to 200 degrees. So X will give us 200 degrees. Okay, so in respect to this question, I've shown you how you can derive your alternate angles out, and also how you can derive your corresponding angles and vertically opposite angles. So from what we have solved now, you can see that 120 plus Y, let me take a recap, is equals to 180. That's sum of angles on a straight line. We're able to find y. Okay, and on this other side, z plus 80 is equals to 180. Angles on a straight line too, we're able to find z as 180 minus 80. That gave us 100 degrees. Now, in this place, we were asked to find x. We needed to, draw a line here. When you are given a shape to solve, you can always alter this shape in a way if you don't change the original equation. This place I'm having x here is angle at a point, but I needed to find these other angles on the right hand side opposite that x, and I cannot do that successfully if I don't draw another imaginary alternate angles to divide that place into two. Now, once that place is divided into two, I can say that 60 degrees vertically opposite to y is alternate to one of those angles, and also z that was 100 degrees is also alternate to the other angle below. So with that, we can be able to now find x as angle at a point with those other angles. Alright, so that is how these theorems of angles formed by parallel lines can help us when we can identify corresponding angles, when we can identify alternate angles, and when we can identify vertically opposite angles, not forgetting interior opposite angles to be supplementary. So this is a typical example. This is a typical example of how we can evaluate angles formed by parallel lines. Don't go anywhere. In the next video, we'll be discussing the triangles and of course the theorems that we will use to be able to evaluate mathematical exercises involving the triangle. See you.